We discover something and we say, oh, we're limited by the laws of physics. But the laws of physics don't care where you live. They're not prejudiced. They're not going to say, well, these aliens on this planet over there, we'll give them special treatment. No, the mathematics works the same way. The speed of light is the speed of light whether you're here or 10,000 light years away. You know what's interesting? We have this assumption in our heads. We assume that technology will just keep advancing forever, exponentially, doubling every few years, every decade. We look at the last 400 years and we see this insane progress. Moore's law, computers getting faster, everything getting better. And we think, well, this will never stop. But why should we think that? I want to ask you something. What if the actual ceiling on technology is much, much lower than we think? What if there are problems that you cannot solve with any amount of energy, any amount of cleverness? Think about that for a minute. Let's say you want to understand something at the deepest level. You want to know what happens at the smallest possible scales. So you build a bigger and bigger experiment to test your ideas. You need more energy. You need more particles. You need bigger machines. But here's the catch. The energy required to test each new level of knowledge doesn't go up linearly. It goes up exponentially. At some point, you would need so much energy to do the next experiment that it's not practical. And I don't mean with your current technology. I mean, period. No civilization could build it. Now imagine a civilization 1,000,000 years ahead of us. They've solved energy production. They've got fusion down perfectly. They've got all the engineering problems we have. They've crushed them. But they still hit this wall. Because it's not about having enough energy or being clever enough. It's about what the laws of physics actually allow. This is what some people are calling the universal limit to technological development. And I know that sounds like jargon, but the idea is actually quite simple. The idea is that there might be a point, not a point where we don't know how to go further, but a point where you cannot go further. Where it's not that we're ignorant. It's that nature itself says, no, you can't do that. Think about the speed of light. We know this one. Nothing can go faster than light. This is not a practical limitation that we'll overcome someday with better engineering. This is a fundamental law. It's baked into the structure of space and time itself. You could have the most advanced civilization possible, with technology so far beyond ours that we couldn't recognize it as technology, and they still cannot send a signal faster than light. But here's what I wonder. What if there are other limits like this? Limits we haven't discovered yet because we haven't hit them? What if the structure of space and time, or the nature of information, or something about consciousness? What if some of these fundamental things have built-in barriers that stop any civilization, no matter how advanced? You see, when we think about aliens, we often think about them as just humans with different heads. We put them in our movies looking like us, or like octopuses, or something. But they still think like us. They still want the same things. They still ask the same questions. But what if that's wrong? What if the way they think about physics is completely different? This is fascinating to me. We've discovered the laws of physics by being conscious creatures in this particular universe, with these particular senses. We see electromagnetic radiation in a tiny little window, visible light. But most of the universe is invisible to our eyes. Radio waves, infrared, ultraviolet, X-rays. We built machines to see these. And then we built theories to explain what we saw. But the theories, the way we think about physics, is shaped by what we can measure, by what we can test. An alien species might have different senses, different native way of perceiving the world. And you know what? They might build a completely different physics. They might ask completely different questions about nature. And here's the really interesting part. They could still get all the same experimental results. They could still build technology that works. But the way they think about it, the framework, could be utterly alien to us. We have different ways of describing motion right now, and I'm talking about on Earth, among us. You can use Newton's laws. You can use energy methods. You can use something called the principle of least action, where nature chooses paths that minimize something we call action. For practical purposes, these are equivalent. They give the same predictions, but they emphasize different concepts. They tell different stories about what's really happening. Now, an alien species might go with one of these from the beginning and never feel the need to explore the others. They might develop their entire civilization around that one framework and never develop anything like what we call physics at all. They'd have a complete, functional understanding of how to manipulate the universe, They could build amazing things, but they would be thinking about it in a way that's radically different from us. This connects to something else I want to talk about, which is the Fermi paradox. This is a great puzzle. Drake came up with this equation, the Drake equation, trying to estimate how many communicative civilizations are out there in the galaxy. And the equation looks simple. It's the number of stars times the fraction that have planets, times the fraction with life, times the fraction with intelligent life, and so on. When you multiply it all out, you get a huge number. Millions, maybe billions of civilizations in our galaxy alone. But here's Fermi's question. Where are they? We've been listening for signals. We've pointed our radio telescopes at the sky for 50, 60 years now. Nothing. Where's everybody? Why is the universe so quiet? And people have all kinds of answers. Maybe they all destroy themselves. Maybe they're hiding. Maybe they don't want to talk to us. Maybe they're all existing in virtual realities and don't care about the physical universe anymore. All of these are possible, but I like this other answer. Maybe they can't get past a certain point in technology. Maybe something about the physical universe is like a natural bottleneck that prevents any civilization from becoming a spacefaring civilization. Think about the energy requirements. Space travel is expensive. It's really expensive, not just in money, in pure energy. You need to lift mass against gravity. You need to protect your spacecraft from radiation. You need life support for long journeys. The resources required are enormous, and these resources come from the planet. You can extract so much from a planet before you start degrading it. Now, a civilization might reach a point where they've taken so much from their planet that the ecosystem starts breaking down. The climate changes, the biosphere collapses, and they can't go further because their own technology, paradoxically, has made it impossible for them to survive long enough to reach the next level of technology. It's like they're climbing a ladder, and every rung they grab pulls the ladder down a little bit more. Eventually, the ladder is too damaged to climb anymore. This is happening on Earth right now, in a way. We're burning fossil fuels, we're changing the climate, we're depleting resources. And it's not clear to me that we can reach sustainable spacefaring technology before we've damaged our own environment too severely. We might be hitting that bottleneck. Other civilizations have probably hit it too. Or, and this is really interesting, maybe the problem is that technology itself requires a certain complexity, and complexity has costs. You need a lot of social infrastructure to maintain an advanced technological civilization. You need educators, engineers, scientists, logistics people. You need a whole society organized around that goal. But the more complex your society becomes, the more fragile it becomes. I was struck by something I read about this. They were comparing it to human civilizations throughout history. You have civilizations that rise and fall. The Roman Empire, for example, at its peak, it was incredibly advanced. They had concrete, aqueducts, roads. They had communication across vast distances for the time, but maintaining all that required enormous resources and organization. Eventually, the cost of maintaining that complexity exceeded what the civilization could sustain, and it fell. What if civilizations in the cosmos go through the same cycle? They rise. They develop technology. At some point, the effort to maintain and expand that technology starts to exceed what the civilization can manage. It becomes top-heavy, and then it falls. Now, let me talk about something else. This question of whether aliens would even understand physics the way we do. Because I think this gets at something really fundamental about how we discover things. Science, the way we do it, starts with a question. Why? Why do things fall? Why does fire burn? Why does the sun shine? We're driven by a kind of curiosity that's almost human. We want to understand. We want to get at the essence of things. But what if not all intelligent species are driven by that desire? What if an alien species valued something else? Reliability, maybe, or usefulness. They might develop incredible technology without ever asking, but why does it work? They'd have recipes for making things work, but not understanding of the underlying principles. Or even more interesting, what if they just value different kinds of questions? We ask, what are the fundamental forces? But maybe they ask, what are the patterns of harmony? Or how does information flow? Maybe their framework for understanding nature is based on concepts we don't even have words for. You see, physics as we have it is the cumulative result of a lot of human choices. Not conscious choices, exactly, but choices implicit in our history, our tools, our values. We chose to focus on fundamental forces. We chose to value prediction and control. We built mathematics to help us understand motion and energy. But all of this came from our particular position in history, with our particular brains, our particular technology. An alien species starting from scratch, with different perceptions and different values, might build something completely different. And it would work for them. It would let them predict and control their environment. But we might not even recognize it as physics. This connects back to the question of technology. Because if you don't have a framework for understanding the deep principles of nature, you might get stuck. You might be able to refine your existing technology, make your rockets better, make your materials stronger, but you might not be able to make the conceptual leaps needed for real advancement. Some scientists think that if we met aliens that were, say, only a few hundred years ahead of us technologically, that would actually be pretty surprising. Because if they're farther away from us in time than we are from the Middle Ages, they should be incomprehensibly more advanced. If they're not, maybe it's because something stopped their development. Let me think about this another way. There's something called the speed of light that's been bothering humans for a long time now. It's a fundamental limit. Nothing can go faster than light. But let's think about what that means for space colonization. The nearest star to us is 4 light years away. If you could build a spacecraft that traveled at half the speed of light, which is absurdly fast by our current standards, it would take 8 years to get there. But you need to accelerate to that speed, decelerate when you arrive, maintain a spacecraft that keeps humans alive for that long, and have resources for them when they land. The next nearest star might be 10 light years away. Then there's another 30 light years away. Space is big. It's unimaginably big. To colonize the galaxy, you'd need a civilization willing to send out thousands and thousands of spacecraft, knowing that most of them will be out there for centuries, that the vast majority will never contact home, that the radiation and cosmic rays and micrometeorite impacts will be constantly damaging them. It's possible. I'm not saying it's impossible, but it's so expensive, so resource-intensive, so psychologically demanding, that you could imagine most civilizations never bothering, or trying and failing, or reaching a point where they say, you know what, this isn't worth it. This is actually a profound thought. Maybe the galaxy isn't full of colonial empires of aliens spreading everywhere. Maybe the default is that civilizations stay at home. They might have amazing technology. They might be able to do things we can barely imagine, but they just don't expand into space. Now, I want to bring this back to something fundamental about physics and what it means to understand the universe. Feynman, well, I suppose I should say, I've always believed that if you truly understand something, you can explain it simply. You can build it. Knowledge and technology are intimately connected. What you can understand, you can eventually create. What you cannot create, you don't really understand. But the flip side of this is also true. There are limits to what you can understand because of the universe itself. Not because of human limitations, but because of how the universe is structured. For example, quantum mechanics tells us something profound. You cannot measure certain pairs of properties with arbitrary precision at the same time. The more precisely you know a particle's position, the less you can know about its momentum. This isn't a limitation of our instruments. It's built into the fabric of reality. An alien civilization, no matter how advanced, cannot get around this. And there might be other limitations like this that we haven't discovered yet. There might be fundamental constraints on how much information can flow through space. There might be limits on how much mass or energy you can concentrate in one place without creating a black hole. There might be principles we don't know about yet that prevent certain kinds of technology entirely. One thing that strikes me about this whole question is that we ask it from such a position of confidence. We assume that technology is always good, always advancing, always expanding. But why should that be true? Why should we expect civilizations to want to get bigger and more powerful? Maybe at some point, a civilization gets wise and thinks, actually, we have enough. We can feed our people. We have art and music and philosophy. Do we need to conquer the galaxy? Do we need to build bigger and bigger things? Maybe maturity in a civilization means learning to be satisfied with what you have. I'm not saying that's what happens. I don't know. But I'm saying it's possible. And it's worth thinking about. Because we're assuming the universe is full of aggressive, expanding, colonizing civilizations, and maybe it's not. Maybe it's full of civilizations that got smart enough to stop before they destroyed themselves. Here's what I think is really going on with this question of alien technology. We're asking a deep question about the nature of progress and the nature of limits. We're asking, is there always a way to go further, or are there fundamental barriers that even infinitely advanced beings cannot overcome? And the honest answer is, we don't know. We haven't thought about it long enough. Physics has changed before. Newton gave way to Einstein. Classical mechanics gave way to quantum mechanics. And we're still learning. Maybe in another 100 years, physicists will discover something that completely changes how we think about technology and what's possible. But what we can say right now is this. Every single thing we know about the universe suggests that there are constraints, hard limits, the speed of light, the laws of thermodynamics, the Pauli exclusion principle that keeps atoms from collapsing into themselves. The universe is not infinitely malleable. It has rules. And if we're ruled by those same laws, then any aliens are too. They might be incredibly clever. They might have solved problems that seem insurmountable to us. They might have technology that looks like magic, but they're not exempt from the rules. They're playing the same game we are, with the same board, with the same rules, which, when you think about it, is kind of beautiful. It means that the universe has a kind of uniformity, a kind of democratic fairness. No one gets special treatment. Not us, not aliens, not anyone. We're all limited by the same things. We all face the same wall eventually. And maybe, just maybe, they hit the wall before they ever left their home planet. And they're sitting there right now, millions of light years away, wondering the same thing we're wondering. Is there anyone else out there? And they're sitting in silence, just like we are, because everyone hits the wall. That's what I find fascinating about this question.